Your organization invests in automation with one assumption: it saves time. Fewer manual tasks, faster processes, less operational drag. But here's what actually happens. You end up with dozens of disconnected scripts scattered across different environments. You have different owners and different failure modes. When the person who wrote the script leaves, the process breaks. When you try to scale it, the whole thing fractures. And somehow, the automation you built to save time now consumes more time than the manual work it replaced. Most organizations treat automation as a series of hero scripts. One person builds something to solve an immediate problem, and it works for a while. Then it becomes a liability. It stays unmaintained, undocumented, and fragile. When you add that to 50 other scripts in the same environment, you create a technical debt problem. It doesn't show up in your budget until the day it completely breaks. This isn't about writing better PowerShell. This isn't about finding the right connectors. This isn't about scheduling tasks more efficiently. This is about recognizing a shift. By 2026, the organizations actually winning aren't the ones with the fastest scripts. They're the ones with platforms that don't require heroes. They are the ones that shifted from fragile point-to-point automation to orchestrated, governed, autonomous systems. The difference between these two approaches is not incremental, it's architectural. Let's start by diagnosing where your organization actually is. The maturity trap. There's a common assumption about automation. It follows a linear progression. You start with manual work, then you write a script, then you schedule it, then you integrate it, and then you're done. That's the theory. In reality, it's a trap. Most organizations are stuck in the script consolidation phase. They have dozens of PowerShell scripts running across on-premises infrastructure, Azure, task schedulers, and logic apps. They use Power Automate alongside legacy tools, but nobody actually knows which ones are still being used. Nobody knows who owns them. And when something breaks at 2 a.m., the organization reaches out to the person who wrote it 3 years ago. That is, assuming that person still works there. This isn't a technology problem. It's an architecture problem. The 5 levels of automation maturity exist, but they're not sequential in most enterprises. They exist concurrently. You're running all 5 at the same time, and that creates fragmentation and operational chaos. Manual work still happens because the automated solution broke or was never documented. Scripts exist in repositories nobody can find, running on servers nobody remembers. Integration attempts have created dependencies that nobody fully understands. So what's actually happening is the model is failing. Organizations that have moved past this phase look different. They're not the ones with the most developers or the fastest code. They are the ones treating automation as a strategic capability instead of a collection of scripts. They move 3 times faster than everyone else. Not because their individual scripts are better, but because their systems thinking is better. The diagnostic question separates them. Do we have orchestration? Orchestration means when one process completes, the next one knows it completed. It means when something fails, the failure is visible and recoverable. It means when you add a new integration, you're not creating another point-to-point cable. You're plugging into an existing fabric. Most organizations don't have that fabric. They have a collection of cables. Each one was added independently. Each one requires its own maintenance. Each one fails independently. The cost of fragmentation stays invisible until you try to scale. That's when it becomes catastrophic. 50 scripts can survive through heroic effort, but 500 scripts cannot. The only path forward is rebuilding the foundation. Organizations at that breaking point face a hard choice. You can keep patching the script model, or you can rebuild around platforms. The shift isn't about faster scripts or more connectors. It's about adopting a different mental model entirely. Understanding where you are is the first step. The second is understanding what orchestration actually means in the Microsoft ecosystem. What orchestration actually means. Orchestration isn't a tool, it's a pattern. In the Microsoft ecosystem, orchestration means that Graph becomes your central nervous system. This isn't because Graph is special or proprietary. It's special for one specific reason. It is the only unified interface for your Microsoft 365 data and identity. Everything you use, Exchange, SharePoint, Teams, OneDrive, and Entra ID, is accessed right there. When you build a script that reads from Exchange and writes to SharePoint, you are just creating a point-to-point connection. Data flows in one direction. 2 systems have to know about each other directly. But when you build an orchestration layer that routes that same data through Graph, you create something different. Now, the systems don't need to know about each other. They only need to know about the orchestration layer. The difference isn't academic, it's operational. A point-to-point connection breaks the moment an endpoint changes. If the Exchange API changes, your script breaks, and if the SharePoint API changes, your script breaks again. An orchestration layer survives those changes because the layer itself becomes the contract. The endpoints can change, but the interface between the system and the orchestration layer stays the same. Here's what that looks like in practice. Imagine a workflow that needs to react when a new email arrives. In the old script model, you write a scheduled task that polls Exchange every 5 minutes. The system asks if anything changed. 5 minutes pass and nothing happens. 5 more minutes pass and it's still quiet. Then an email finally arrives, but the system only finds out about it 5 minutes later. if you are lucky. In the orchestration model, you create a graph subscription instead. You tell the system to let you know the second an email arrives. The system doesn't guess and it doesn't poll. When that email hits the inbox, the system knows immediately. But here is what most people miss. The subscription alone isn't enough. Subscriptions can expire or be missed, and they often fail silently without anyone noticing. So the orchestration layer does something counterintuitive. It pairs the subscription with a delta query that periodically reconciles the state. You schedule it to run once a day, and the delta query asks SharePoint what changed since the last check. If the subscription missed something, the delta query catches it. And if the subscription failed entirely, the delta query is your backup. This isn't redundancy. This is resilience. You get the speed of an event-driven architecture combined with the reliability of a batch reconciliation. This pattern is now the standard. In 2026, the organizations that are winning understand this distinction. They aren't building faster scripts, they are building systems that remain reliable when things break. The shift from scripts to orchestration is really a shift in how you think about causality. In a script, you are saying, do this, then do that. You execute step 1, wait for it to finish, and then execute step 2. In an orchestration, you are saying, when this happens, the system responds. The system becomes an actor. It observes, it reacts. It doesn't wait for someone to tell it what to do next. This matters because it changes who is responsible. In a script model, the person who wrote the code is responsible for what it does. When something goes wrong, you have to call that person. In an orchestration model, the system itself is responsible. The person becomes the architect who designed the system, not the operator who has to maintain it. That's why this shift is hard. It requires organizations to admit that the hero script model doesn't scale anymore. It requires rebuilding the foundation and thinking about systems instead of individual tasks. But this is also why the organizations doing this are moving so much faster. Once the foundation is solid, adding new capabilities becomes trivial. You aren't writing new scripts. You are just adding new rules to an existing fabric. Understanding the pattern is one thing, but implementing it requires knowing what infrastructure actually supports it. We need to talk about what that looks like in 2026. The infrastructure layer, choosing your foundation. By 2026, the infrastructure choices have consolidated. You aren't choosing between dozens of options anymore. You're choosing between 2 different patterns. And each one has clear economic and operational trade-offs. The first choice is about where you orchestrate. Do you want to do it at the workflow level or the compute level? Workflow level orchestration means you are using logic apps or Power Automate. You define processes visually and use pre-built connectors to get things moving. You're thinking in terms of steps and conditional branches. You drop a trigger, add your actions, and wire everything together without writing a single line of code. Compute level orchestration means you are using Azure Functions or durable functions. You're writing code and thinking in terms of algorithms and state machines. You are optimizing for performance and controlling your costs at a very granular level. These aren't equivalent choices. They are different answers to different problems. And organizations frequently choose wrong because they don't understand the distinction. If your automation is mostly about connecting systems, reading from one, transforming data, and writing to another, workflow level orchestration is faster to set up. A logic app that reads from SharePoint and writes to Dataverse is straightforward because you don't write code. You just wire connectors. A function that does the same thing requires actual development, testing, and deployment cycles. But if your automation is about computation, complex business logic, or high-volume processing, compute-level orchestration is more cost-effective. You aren't paying for every step. You're paying for the actual execution time. But here is what most organizations miss. The choice isn't binary. The winning architecture in 2026 uses both. You use logic apps for orchestration and functions for computation. The logic app defines the workflow and acts as the conductor, while the function handles the heavy lifting like an instrument. This hybrid approach gives you the maintainability of visual workflows with the power of custom code. The cost implications are significant. A logic app that does heavy computation is expensive because you're paying for every action, including every loop and every retry. Each iteration costs you money. A function doing that same work is cheap because you only pay for the actual compute time. If you are processing 1 million records, the difference between $5,000 and $500 is catastrophic. This is where the distinction between an algorithm and a process map becomes critical. If you're building a process map where each step is about routing or transformation, logic apps are the right choice. You aren't doing complex math, you're orchestrating. But if you're building an algorithm that requires loops and heavy logic, functions are the way to go. You're computing, not orchestrating. Most organizations get this backwards. They build complex algorithms in logic apps because that is what they know, and then they are shocked by the bill. They see the cost and realize they should have written a function instead. The diagnostic is simple. Understand what you are actually building. Are you orchestrating a workflow or are you computing a result? The answer changes everything about how you architect the solution. The infrastructure choice is between workflow level and compute level orchestration. Workflow level is faster to implement but gets expensive at scale, while compute level requires more code but saves money on actual computation. The winning 2026 architecture uses both. This hybrid approach is now the standard practice. Organizations that understand this distinction are building systems that scale efficiently, while those that don't are just accumulating technical debt with every new automation they add. Choosing the right infrastructure is half the battle. The other half is making sure it's reliable. That means understanding how things fail and building for recovery. The reliability problem. Why most integrations fail silently. Here is a scenario that plays out in enterprise environments every single day. Almost nobody notices it until the damage is already done. You build an integration. It works perfectly for 6 months. Everything runs smoothly. Then one day, without a single warning or notification, it just stops. It isn't an obvious crash. There is no error message for anyone to see. It just goes quiet. 3 weeks pass by. Nobody's looking at the output. Then, someone finally realizes that critical data hasn't moved in 21 days. This happens constantly because most integrations are built without a reconciliation layer. There is no verification. There is no source of truth to check against. The assumption baked into these systems is that if something fails, someone will notice. In reality, nobody notices. A webhook that stops being delivered doesn't send you an error message. A scheduled task that gets disabled doesn't trigger an alert that anyone is actually monitoring. A connection that times out doesn't log an event in a place where the right person will ever see it. The only way to actually know if an integration is working is to verify its output against something authoritative. You have to check the work. You cannot just assume it happened. This is what reconciliation does. It isn't about optimization. It isn't about redundancy. It is failure detection built into the architecture itself. Here is how this looks in practice. You create a graph subscription that watches for new files in a SharePoint library. When a file is created, the webhook triggers a function that processes it. The webhook is fast, the response is immediate. The system processes the file. Everything works, except webhooks fail. They get missed, they expire, they time out silently. So alongside that webhook, you schedule a Delta query to run once a day. The Delta query asks SharePoint directly, what files have been created since my last check? If the webhook missed something, the Delta query catches it. If the webhook failed entirely, the Delta query is your backup. If both failed at the same time, you would know because the reconciliation would report a gap. The cost of running a daily Delta query is negligible. You are talking about a few dollars per month. But the cost of discovering 3 weeks later that critical business data hasn't moved is catastrophic. Orders get delayed, compliance gets missed, revenue gets lost. The math isn't even close. Yet most organizations don't do this. They build the webhook, they test it in staging, they deploy it to production, they assume it will keep working, then they are shocked when it doesn't. The diagnostic question for your organization is straightforward. For each of your critical integrations, do you have a reconciliation mechanism? Not a hope it works plan, an actual mechanism that verifies the work happened. If the answer is no, your integrations are fragile. The shift from hope it works to verify it works is the shift from scripts to platforms. Scripts assume success. They are built with the expectation that everything will function as designed. Platforms are built with the opposite assumption. Things will fail, and you need to detect and recover from those failures. This architectural difference is why organizations with platforms are more reliable than organizations with scripts. It isn't because their code is better written. It isn't because their developers are smarter. It's because their systems account for failure as a first-class design requirement. Silent failures are expensive. The organizations that have figured this out have built infrastructure that makes silent failures impossible. The identity, heartbeat, why managed identities are non-negotiable. Every automation system has a pulse. It is the rhythm at which credentials refresh, permissions get verified, and the system confirms it still has the ability to do what it was built to do. In 2026, that pulse is approximately 45 days. That is the rotation cycle for Azure Managed Identities. Here's what that means in practice. Every 45 days, Azure automatically creates a new credential for your managed identity and revokes the old one. The system doesn't ask for permission first. It doesn't send you a notification. It doesn't wait. It just does it. And if your automation isn't designed to handle that rotation, it will break silently. This isn't a bug. This is a feature. Static credentials are a security liability. If you have a credential that never changes and someone steals it, that compromised credential remains valid forever. An attacker has permanent access. If you have a credential that rotates every 45 days, a stolen credential has an expiration window. The exposure is bounded. This is security by design, not by hope. The operational consequence is significant. Your automation cannot store credentials in code. It cannot keep them in configuration files. It cannot persist them anywhere that requires manual intervention to update. Because if the credential rotates automatically, but your system is still using the old one, the connection dies. This is where managed identities become essential. A managed identity is an identity managed by Azure itself. You don't create the credential, you don't rotate it, you don't delete it. Azure handles the entire lifecycle. Your code simply uses it. The pattern is straightforward. Your function or logic app authenticates with a managed identity. That identity has the specific permissions it needs to do its work. When the credential rotates, the system automatically uses the new one. Your code doesn't know rotation happened. It doesn't care. It keeps working. But most organizations miss the mental shift this requires. With traditional service accounts, you create an account, assign permissions, and then manage it for years. The account stays the same. The permissions stay the same. You control it entirely. With managed identities, you create the identity, assign its permissions, and then Azure takes over. You don't control the credentials anymore. The system does. This feels like losing control to organizations accustomed to managing infrastructure. It is actually the opposite. You are trading away the burden of credential management for genuine reliability. The system handles the complexity that humans invariably mess up. Rotation schedules, secure credential storage, renewal before expiration. The trade-off is precision with a service account. You might assign it broad permissions because you are managing it anyway. The risk feels acceptable since you know what the account can access. With a managed identity, you have to assign exactly the permissions it needs. No extras. No, it might need this later. Because you aren't managing it anymore. The system is, and the system enforces boundaries. This constraint forces a discipline most organizations lack. It forces you to think about least privilege. It forces you to ask exactly what each automation is allowed to do, nothing more. This security discipline doesn't come from policy or training. It comes from the architecture itself. The diagnostic is direct. Do any of your automations use stored credentials or connection strings? Do they read passwords from configuration files or key vault? If the answer is yes, those automations are fragile. They are built on the assumption that credentials stay static forever. They are not ready for 2026. The fundamental shift here is moving from we manage credentials to the system manages credentials. The first model creates operational overhead. Every rotation is a manual event. Every compromise requires investigation and a credential reset. The second model distributes that overhead to infrastructure. It handles it automatically and consistently. Organizations making this transition discover something. They aren't losing control, they are gaining it. The system becomes more reliable. Automations stay functional across credential rotations. Security posture improves because credentials change constantly. The only thing humans have to do differently is think more carefully about what permissions each automation actually needs. Credentials are just the entry point to the identity layer. The larger architecture question is how you govern who gets to create automations in the first place, and what they are allowed to touch with those automations. Governance as infrastructure, the policy as code shift. Most organizations fail to scale automation because of one uncomfortable truth. They think governance is a document. They treat it like a list of rules that someone writes down and everyone eventually ignores. But in reality, governance is infrastructure. By 2026, the companies with governance that actually works are the ones that started treating it as code. They moved away from policy documents and review committees that just check boxes. Instead, they built actual infrastructure that makes certain mistakes impossible to commit in the first place. This might sound like more bureaucracy, but here's the problem. It's actually the opposite. When you want to build a new automation, you don't fill out a form and wait for a committee to give you the green light. You can't even try to break the rules because the system won't let you. The guardrails are baked into the technical environment itself, making the gates technical rather than administrative. Suppose you have a policy stating that no automation can use a service account with access to production data. In the old model, this was just a sentence in a PDF that a tired employee had to manually check for every single project. Eventually, that person misses something, automations slip through, and the rule becomes a total fiction. In the new model, the system simply blocks you from creating that automation. If you try to assign the wrong permissions, the system rejects it immediately. It isn't possible to bypass the rule because there is no workaround or exception process. The architecture enforces the rule so people don't have to. This sounds restrictive, but in practice, it's liberating. Once those guardrails are active, you can move at high speed without asking for permission or waiting for a compliance meeting. You can build whatever you want within the bounds the system allows, knowing it's compliant because the system literally won't let you build it any other way. This is the shift from governance as a constraint to governance as enablement. The guardrails don't slow you down. They let you move without friction because you know you're always safe. In a real-world setup, you define these policies as code using tools like Azure Policy for infrastructure or Entra ID conditional access for identity. You might use Purview for data boundaries, but the specific tool matters less than the fact that the system is doing the enforcing. For example, a policy might require a data owner to approve any automation accessing customer info. In the old model, a human checks for that approval. In the new model, the system won't trigger the automation until the automated workflow notifies the owner and they click a button. This isn't a manual review, it's automated governance. Setting this up is difficult. It forces you to think deeply about which policies you actually need versus what just sounds nice to have. You have to build the enforcement layer and change how your entire team thinks about the work. But the payoff is massive once it's running. Your automation becomes trustworthy because the system guarantees it, and your security team can finally sleep because certain mistakes are now physically impossible. The organizations winning in 2026 didn't get faster by having fewer rules. They got faster because their rules are automated. The system handles the compliance, so the people can handle the innovation. Governance is the foundation, but the real power shows up when you layer orchestration and reliability on top of it to create a platform that scales without collapsing. The agent layer, from automation to autonomous systems. By 2026, the conversation has fundamentally shifted away from how we automate a task. Now, the only question that matters is, how do we make the system autonomous? The difference is profound, and it changes everything about how you design your systems. Automation means you are telling the system exactly what to do. You script out every step, telling it to read a file, process the data, and write a report. It executes those steps in order and does exactly what it's told, nothing more. Autonomy means the system decides what to do based on the context it sees. It observes a situation, reasons through the problem, and takes action without waiting for a human to prompt the next step. The system becomes an agent that acts on your behalf. This is where real agents come in. I'm not talking about fancy names for scheduled tasks or complex scripts. I mean systems that can understand a situation and decide on a course of action entirely on their own. The infrastructure making this possible is Agent 365, which hit general availability in May of 2026. Agent 365 acts as the control plane for agents across the entire Microsoft ecosystem. It's where you register them, manage their permissions, and monitor their behavior to keep them under control. But here's the part most people miss. Agent 365 isn't the agent itself. It is the infrastructure that makes those agents safe to use. Think of it as the operating system for autonomous systems. An agent without governance is a massive liability. It's a black box that does things without anyone knowing why, making it impossible to audit or trace. But an agent with governance is different because the system knows exactly what it did and why it did it. In practice, these agents operate with specific identities and very tight permissions. An agent designed to process orders cannot delete customer records because the system enforces those boundaries at the architectural level. This is like managed identities for your automations, but you're managing the entire lifecycle of a thinking system. By 2026, the winning organizations are treating agents as first-class citizens in their infrastructure. They aren't experiments or toys. They are actual workers doing critical, high-stakes work every single day. This requires a total shift in your mental model. You have to anticipate what an agent could do wrong, build safeguards, and monitor its behavior every second it's running. You need a plan to shut it down instantly if things go sideways, planning for agent failure the same way you plan for a server going down. Once that infrastructure is solid, the productivity gains are staggering. An agent that can process an order, check inventory, and route fulfillment without a human involved is worth millions in operational efficiency. The shift from automation to autonomy is really a shift from tools to workers. You aren't building a script that performs a task. You are building a system that works, observes, and reports. Agents are the new frontier. But before you can deploy them safely, you need a foundation of orchestration and reliability that actually works. Let's look at what that foundation looks like in a real organization dealing with real business pressure. The architecture in practice, a real-world blueprint. Let's take these pieces and look at how they actually work together in a system that's running in production right now. Most organizations face a common problem where customer orders arrive from too many different places. Some come through the website, others through a partner API, and some even arrive via email. You need to validate every single one against your inventory, route it to the right fulfillment center, and update the ERP system. Usually this is handled by 4 different scripts, running on 4 different schedules, owned by different people and failing independently. But here's the problem. When one script breaks, the whole chain stops, and nobody knows why until a customer complains. Here is how you architect this using the platform model. First, you set up graph subscriptions to watch your primary data sources. When a new order hits the CRM, the subscription fires. When one arrives in the web API or the email system, other subscriptions fire. These subscriptions aren't doing the heavy lifting. They are just signals. They tell the orchestration layer that something happened. When a subscription fires, it triggers a logic app. The logic app is your conductor. It acts as the process map that orchestrates the entire workflow. It reads the incoming order, extracts the customer info, and formats the data so it looks the same every time. Then it calls a function. That function is where the complexity lives. It validates the order against inventory rules and checks stock levels across different warehouses. It handles the messy edge cases and the pure computation. The logic app doesn't care how the math works. It just knows that when it sends an order to this function, it gets back a result or an error. If the validation passes, the logic app routes the order to the right fulfillment center and updates the ERP. It sends the customer a confirmation and logs the status in the CRM. Every single one of these steps is protected by a managed identity. This identity can read orders and write instructions, but it can't delete data or touch payment info. The system enforces these boundaries because you define them during setup, making them permanent and unyielding. But you don't stop at the subscription. You also schedule a daily Delta query. It asks your systems what orders arrived that haven't been processed yet. If a subscription expired or a webhook failed while the logic app was down, the Delta query finds the gap. It reprocesses any missed orders so the business doesn't have holes. The system is resilient by design. All of this is governed by policy. You can't create a logic app that bypasses the validation function because the infrastructure prevents it. You can't give the orchestration identity permissions it doesn't need because the governance policies will reject the assignment. The system enforces the rules you set. You've also set up monitoring. You're watching the subscriptions to confirm they're delivering and checking the function to ensure it's processing correctly. If any step fails, you get an alert immediately. It's not a silent failure discovered 3 weeks later. It's an immediate notification. Now, look at what happens when things change. Someone leaves the organization. The person who knew everything about these systems and built the original scripts years ago takes a job elsewhere. In the old model, that's a disaster. In this model, the system keeps working. It doesn't depend on a person. It depends on infrastructure. The business might change its fulfillment rules. If the validation logic needs to be different, you just change the function. You test it and deploy the new version. The logic app doesn't even know anything changed. It just keeps calling the function. The orchestration stays the same. You didn't have to rebuild the infrastructure, you only changed the code. If you need to add a new data source for orders, you just create a new subscription for that source. It triggers the same logic app and the same validation function. You aren't writing a new script from scratch. You're just plugging a new input into an existing fabric. This system is more complex than those 4 original scripts. It requires more infrastructure thinking at the start, but it survives things the scripts couldn't. It survives people leaving, requirements changing, and systems breaking. This is the shift from scripts to platforms. The complexity is upfront, the payoff is continuous. The migration path, from scripts to platforms. Every organization that has built automations eventually asks the same question. They want to know how to get from where they are to where they need to be. The worst answer is to rebuild everything. That is the path that kills projects. It means shutting down your existing scripts and trying to start over from scratch. You'll discover midway through that you missed something critical the business depends on. Then you'll scramble to put the old system back into production while the new system sits there incomplete. The path that actually works is incremental. You keep your current system running while you build the platform alongside it. You migrate one automation at a time, learning from each move and improving the process. Then you do the next one. This takes longer than a big bang rewrite, but it's the only approach that doesn't break the business. Phase 1 is the assessment. You need to inventory every automation you have right now. You identify which ones are critical and which ones would tank the business if they stopped working. You need to understand how they fail and how often people have to step in to fix them. You're measuring their actual reliability, not just what people think is happening. This phase takes weeks, not months. You aren't looking for perfection here. You're just building a map of the landscape. You have to know what you have before you can move it. Phase 2 is foundation building. This is where you stop touching the automations themselves. Instead, you build the infrastructure around them. You set up managed identities for your critical systems and implement basic governance policies. You set up monitoring and alerting that actually watches the traffic. The automations stay exactly as they are. You aren't changing their behavior yet. You're just building the platform layer underneath. This phase also takes a few weeks. You aren't doing any migration yet. You're just preparing the ground. Phase 3 is where the actual migration happens. You take your most critical automation, the one that would hurt the most if it failed, and you rebuild it using the platform model. You create the subscriptions, build the logic app, and write the function. You test it thoroughly in a staging environment to verify it's more reliable than the original. Then you do something important. You run both versions at the same time. The old script runs on its original schedule while the new platform automation runs in parallel. Both are processing work and both are writing results. You compare the outputs and watch for any discrepancies. You monitor this for days or even weeks. Only when you are completely confident that the new version works do you switch over. Only then do you decommission the old script. You don't do all 50 of your automations this way. You do the critical one first and document what worked. You improve your process based on those lessons. Then you move to the second one. The second migration is always faster because you've already learned the pattern. By the 10th automation, you've refined the approach enough that new migrations move very quickly. Phase 4 is optimization. Once you have several automations running on the platform, patterns will start to emerge. You'll see that multiple automations need the same validation logic, so you build a shared function. You'll see that they follow the same orchestration pattern, so you create a template. You build shared monitoring and create documentation that helps new teams move faster. This entire path takes years. It might take a year to get through all 4 phases for your first set of critical automations. It might take another year to migrate the second wave. By year 3, you're deep into optimization and building new capabilities instead of just migrating the old ones. But here's what matters. During all of this, the business keeps running. You aren't asking the organization to accept downtime while you rebuild. You aren't asking people to work without their tools while you figure out the new system. You're asking them to keep going while you build something better in parallel. Organizations that fail at this try to do it differently. They decide to migrate everything at once and shut down the old system. Then they discover they missed a detail and the business breaks. They panic and go back to the old system, and the new system gets abandoned. Everyone gets frustrated, and 2 years later they're still running the same old scripts. The organizations that succeed are the ones that accept the pace. They understand that moving slower means arriving intact. Incremental change provides higher confidence than a revolution. Keeping the business running while you rebuild is not slow. It's the only way to actually finish. The business case: why this costs less than you think. The first question every CFO asks about rebuilding automation is simple. How much is this going to cost? The honest answer makes them uncomfortable, because the cost is visible, but the savings are invisible. You're likely paying more right now than you realize. Think about your organization today. You have 50 critical automations running. Some are PowerShell scripts, some are logic apps, others are just scheduled tasks or Power Automate flows. None of them are built the same way. You have no way to reconcile them. You have no governance, you have no real monitoring. When a process breaks at 3 a.m., someone has to wake up, hunt through logs, and fix it manually. You won't find the price of this mess on a single budget line. It's hidden. It's spread across every department in the company. It's the hours your operations team wastes on troubleshooting. It's the business impact of a missed event that nobody noticed until it was too late. It's the security risk of unmanaged identities and the compliance gaps that exist because there's no audit trail. Let's put a number on that invisible drain. In a mid-sized company, that overhead easily hits $500,000 a year. That's a conservative estimate. Now, look at the platform model. Your infrastructure costs about $50,000 a year for things like logic apps, functions, and storage. You spend another $200,000 on labor to have someone design the system and guide the migration. Your total is $250,000. On paper, you just cut your costs in half. But here's the problem. The $250,000 is a visible line item. Everyone sees it. The $500,000 you were spending before was invisible. No one was tracking it. No one knew it existed. They just knew things kept breaking and people kept fixing them. This is why leadership struggles with the investment. A CFO looks at the budget and sees $250,000 going to a new project. That feels like new spending. The fact that you were already burning twice that amount on operational friction doesn't register because the old system never captured the data. But after the first year, the math gets even better. Your infrastructure stays the same, but your labor costs drop. You aren't migrating anymore. You're just maintaining. You might spend $50,000 a year to keep the platform running and onboard new ideas. Now, your total cost is $100,000. You've cut the original spend by 80%. But even that isn't the real win. The real return is speed. Once the platform exists, adding a new automation takes days instead of weeks. When the business needs a solution, you can deliver it in 7 days. Under the old model, you'd quote them 3 weeks and then spend the 4th week explaining why it's delayed. Now you can experiment, you can respond to competitors, you can actually move. That's where the ROI lives. It's not just about saving money on scripts. It's about making the entire business more responsive. The business case is simple if you're honest about the numbers. You are going to pay for automation one way or another. You can pay for it invisibly through overhead, where people are constantly fighting fires and troubleshooting broken scripts. Or you can pay for it visibly through a platform. The visible option is cheaper. If you want to test this in your own office, track 1 month of time spent fixing and maintaining your current scripts. Calculate that labor cost and multiply it by 12. That is what you are already spending. Once you see that number, the conversation changes. It's no longer a question of if you should build a platform. It's a question of who is going to run it. The operational model, who does what. Most organizations fail even after they commit to the platform. They build the tech, but they don't change how people work. In the old script model, ownership was easy. The team that needed the automation wrote the code. They owned it, they maintained it. If it broke in the middle of the night, they got the call. The responsibility was clear because it was tied to one person or one desk. But the platform model doesn't work that way. Individual teams can't own the shared infrastructure. They can't manage the global security policies or the monitoring layer that watches the whole environment. You need a new structure. First, you need a platform team. These people own the foundation. They manage the identities, the governance, and the reconciliation tools. They aren't responsible for every individual automation. They are responsible for the system that makes those automations possible. They are the architects. They design the world, but they don't live in every house. Next, you need automation teams. These are the people who understand the business logic. They know which systems need to talk and why the process matters to the company. They work within the guardrails the platform team set up. When they build something new, they don't start from a blank page. They use the templates. They follow the patterns. Finally, you need a governance committee. This isn't a group that just says yes to everything. It's a decision-making body with people from IT, security, and compliance. When a team wants to automate something involving sensitive data, this committee asks the hard questions. They decide if the risk is worth the reward. This is a big shift for most companies. Usually, IT owns the hardware and business teams own the apps. A dedicated automation platform team is a new concept. And yes, there is a cost to this. You have to assign people to these roles. You need experts who understand monitoring and governance. But the benefit is that the finger pointing stops. If a managed identity expires, that's a platform issue. If the business logic is wrong, that's an automation team issue. If there's a question about data access, that's a governance issue. Everything has a home. When this works, the flow is seamless. A business unit identifies a process that needs to be faster. They talk to the automation team to design the logic. Then they check with the platform team to see what infrastructure is required. The platform team sets up the identity and the monitoring. The automation team builds the flow using the approved framework. The governance committee reviews the access levels and gives the green light. Then it goes live. If something fails, the automation team checks their code first. If the problem is structural, like a failed reconciliation mechanism, the platform team steps in to fix it. This is the only model that actually scales. It's the model where the business can move fast because the infrastructure is designed to support them, not get in their way. The operational model isn't about the software you buy. It's about the people and the process. The model defines how you work, but the real impact happens at the technical level. Let's look at what that actually looks like in practice. The technical execution, building your first platform automation. Let's get concrete about how you actually build your first platform automation. This isn't theory, this is the real sequence. Step 1 is candidate selection. You aren't looking for the most complex automation in your backlog. You're looking for one that meets 4 specific criteria. First, it has to be critical enough that people actually care if it works. It can't be a nice-to-have background process that nobody notices. Second, it has to be simple enough to build in a few weeks. If you pick a project that takes 4 months just to understand, you're going to lose all your momentum. Third, it has to be self-contained. You don't want crazy dependencies on 5 other systems that might change while you're building. Finally, it has to be measurable. You need to know for a fact whether it's working or not. A great candidate is something like syncing employee data from HR into Active Directory when a new hire starts. Everyone understands what the outcome should be. If the sync breaks, people notice immediately. It isn't a trivial task because you're dealing with multiple systems, but it isn't rocket science either. You can wrap your head around the whole thing in about a week. Step 2 is flow design. Don't write any code yet. Don't even open your IDE. Draw a diagram. Map out the entire flow from the input to the output. What triggers the process? What happens next? What decisions does the system need to make? Where does the data actually go? This diagram is your blueprint. Everything that comes after this is just translating that blueprint into infrastructure. For that HR sync, your diagram might look like this. A new hire arrives in the HR system, which triggers a graph subscription. A logic app reads that data and validates it against your domain requirements. Then, a function creates the AD account and the logic app sends a confirmation. Once a day, a Delta query runs to check if any new hires were missed. Step 3 is infrastructure setup. This is where you start touching Azure. You create the managed identities for each component. The logic app gets an identity to read from HR and write to AD, while the function gets an identity specifically to create accounts. You set up monitoring dashboards to watch these components. You create the logic app and the function containers, but you don't put the real logic in yet. You're just building the boxes. Step 4 is testing and staging. You create test data like a fake hire in the test HR system. You trigger the subscription manually and watch it flow through the logic app. You confirm the function gets the right data and verify the AD account is created. You check the monitoring to make sure it captured the event. Then you test the failures. What happens if the AD account already exists? What if the HR data is malformed? You aren't looking for perfection here. You're looking to make sure that when things fail, those failures are visible and easy to understand. Step 5 is the daily reconciliation test. You run that Delta query against your test data. You intentionally inject records that the subscription might miss. You confirm the query finds them and that they get reprocessed correctly. You're verifying that your safety net actually works. Step 6 is parallel operation. Don't switch over from the old system yet. Run them both side by side. The old sync method creates the accounts, and your new platform automation does too. You aren't creating duplicate accounts because you're running the new system against test data while the old one handles production. But you're running it live, at the same frequency, hitting the same systems. You watch it for days. You compare the outputs. You verify the new system handles every scenario the old one did. Step 7 is the cutover. You switch the new automation to production. You keep the old system running as a backup for 1 week. Then you decommission it. This whole process takes time, maybe 3 or 4 weeks for a straightforward process, but by the time you're finished, you have total confidence that it works. And you've built the foundation for the next one. The second automation takes 2 weeks because you've already solved the hard problems. The third takes 10 days. By the 5th one, you're down to 5 days because you've learned the patterns. The first one takes weeks. The second one takes days. This is what scaling looks like. Scaling the platform from one to many. You've finished your first platform automation. It's working. It's more reliable than the old script. It's maintainable, and you understand how the pieces fit together. Now what? Now you build the next one, and the one after that. But here's the shift. The second automation is faster than the first. The third is faster than the second. By the time you've finished 5, you're moving at a completely different speed. By 10, adding new automations is almost trivial. You've built the infrastructure that does the heavy lifting. This is where the real ROI of the platform finally shows up. In the old script model, every automation is an island. You write a script, you test it, and you deploy it. Then you move to the next one. There's no leverage there. There's no sharing components or reusing patterns. The 50th script takes just as much effort as the first one. You aren't accelerating, you're just repeating yourself. In the platform model, every automation builds on the last one. You aren't writing the orchestration layer again. You aren't setting up the monitoring from scratch. You aren't spending weeks on governance policies. You're just building the specific logic for this one process. Everything else is already there. This is the move from linear cost to exponential leverage. The first automation might cost 50,000 to build. The second costs 40,000 because the infrastructure is already there. The third costs 35,000. By the 10th one, you're down to 20,000 per automation. But it isn't just about the money. The quality of what you're building goes up every time. After 5 automations, you'll notice a pattern. A subscription fires, a logic app reads data, a function validates it, and a reconciliation check runs. The pattern is identical every time. So you codify it, you create a template. Now, when a team wants to build something new, they don't start with a blank page. They start with the template and just fill in the blanks. The business logic goes here. The validation rules go there. What used to take a month now takes a week. After 10 automations, a library of functions has emerged. Need to validate customer data? There's a function for that. Need to check inventory? There's a function for that. You aren't writing them again, you're just composing them. After 20 automations, your team has deep expertise. They can spot architectural flaws before they happen. They can suggest optimizations that save thousands in costs. They know where the pitfalls are because they've walked the path 20 times. They know which shortcuts are actually shortcuts and which ones are just traps. This is how platforms scale. It isn't about hiring more people or buying more tools. It's about building better infrastructure. It's about compounding the value of every system into the foundation for the next one. The cost trajectory flips. In year 1, you're investing heavily in infrastructure with only 1 automation to show for it. In year 2, you have 5 automations and the foundation is solid. By year 4, you have 40 automations and the platform is basically running itself. Your team isn't just building anymore, they're guiding, they're optimizing. This is the difference between a project and a product. A project ends. A platform evolves. Evolving requires thinking about what changes over time. It requires building for adaptation, not just for today's requirements. Evolution and adaptation, building for change. Most platform projects die because of one uncomfortable reality. The platform you built today will be useless by 2027. It's not because you failed. It's not because your architects weren't smart enough. It's because the business evolves. Technology shifts. Requirements change in ways you can't predict while you're still laying the foundation. The organizations that actually win don't try to predict the future. They build for it. This means accepting a new truth. Your platform is not a fixed architecture. It's a living system. You're constantly refining it. You're adding capabilities. You're taking lessons from what fails and integrating those insights back into the infrastructure itself. Most people try to future-proof by guessing every possible requirement. But that's where it breaks. You end up with bloated, over-engineered systems that do everything nobody needs and nothing anybody actually uses. Instead, you build for flexibility. You design components that can be combined in different ways. You create patterns that can be extended without having to rip out the whole thing and start over. And you invest in your team. They aren't just maintaining what exists. They're experimenting with new approaches and thinking about how emerging tech applies to your specific build. This isn't slack in your budget, it's how you stay relevant. Look at how this played out in practice. In May of 2026, Agent 365 became generally available. This was a brand new capability that didn't even exist when most platforms were being designed. Organizations with rigid platforms couldn't touch it. It didn't fit their architecture. It was a square peg. To make it work, they would have had to tear out their foundation. So they did nothing. They watched the world move forward while they stayed still. But organizations with flexible platforms had a different experience. They looked at Agent 365 and realized it fit naturally into their model. Because they viewed agents as just another automated system, they could use the same governance and identity layers they already had in place. Within a few weeks, they had agents running in production. They weren't rewriting code, they were just extending the system. The cost difference here is massive. The rigid organization has to choose between spending months on a re-architecture or falling behind. The flexible organization just has to decide how fast they can get these tools into the hands of their business teams. This is the difference between building to last and building to scale. Platforms built to last are rigid. They work perfectly for one specific set of tasks. They're optimized, they're efficient. But the moment the business changes direction, you're exposed. You have to rebuild. Platforms built to scale are different. They aren't optimized for one single thing. They're designed so new capabilities can be bolted on without breaking what's already working. When the business changes, you extend, you don't rebuild. Building for adaptation costs more on day one. You spend more time on the architecture and less time on flashy features. You focus on abstraction and boundaries instead of squeezing every drop of value out of a single line of code. But the payoff is that your platform never becomes a liability. It stays an asset. It stays flexible enough to grab new opportunities. Your team stops fighting the infrastructure, and the infrastructure starts enabling them. The organizations that get this are moving 3 times faster than everyone else. Not because they're typing faster, but because they aren't rebuilding what they already bought. Evolution isn't something that happens to your platform, it's something you design for from the very first day. The future layer, agents, MCP, and autonomous systems. By 2026, the conversation changed. We stopped asking, how do we automate this task, and started asking, how do we make this system intelligent? The infrastructure is already moving. Agent 365 acts as the control plane. The Model Context Protocol, or MCP, is the connectivity layer that lets agents work across systems without moving data around. Graph stays the unified interface, but while the tech is ready, the organizations are lagging. Here's what's actually happening right now. Companies are building agents that can look at a situation, reason through the context, and take action on their own. This isn't a theory, it's in production. An agent can process orders from 5 different sources, flag an exception when the warehouse is low, and coordinate the fulfillment. All without a human telling it what to do next. It works because the infrastructure underneath is solid. But here's the problem most people miss. Without governance, these agents are liabilities. An autonomous system doing the wrong thing is worse than no automation at all. It's doing the wrong thing at scale, with total confidence and without asking permission. But an agent with constraints is different. It has a defined identity. It has limited permissions. Every action it takes is auditable. You know exactly what it did and why it did it. That's when autonomy becomes an asset instead of a risk. Look at the timeline. In 2026, agents became a standard tool. The companies with solid foundations moved fast while the ones still managing individual scripts fell behind. By 2027, the agents got smarter. They started handling complex business-critical processes instead of just small pilots. The gap between the platform companies and the legacy companies became a canyon. Now, look at 2028. That's less than 2 years away. Agents will be genuinely autonomous by then. They won't just follow your steps. They'll make decisions you didn't predict. They'll handle edge cases without asking for help. They'll run 24/7 without oversight. If you have a governance model, these agents become your competitive advantage. If you don't, you'll still be debating if they're safe to use. The winners aren't the ones with the newest toys. They are the ones with the infrastructure ready to use the toys when they arrive. The organizations winning right now treat this prep work as non-negotiable. They aren't waiting for agents to be perfect. They're building the foundation today so they can deploy tomorrow. They have the identities ready. They have the policies defined. They have the monitoring systems built to watch autonomous behavior. The organizations that are behind are still arguing about whether their scripts are reliable. They aren't thinking about agents yet. They aren't preparing for systems that make their own decisions. By the time they realize they need them, they'll be scrambling to build a foundation that should have been finished years ago. This is the frontier. The barrier isn't building the agent. We figured that part out. The barrier is having the infrastructure to govern them safely. The diagnostic for your team is simple, but it's brutal. If you aren't ready for agents, you aren't ready for 2028, and you're running out of time to get ready. Transition. This is the frontier of what's coming. But it's entirely built on the foundation we've been discussing throughout this conversation. Let's assess whether your organization is actually ready for it. Readiness assessment. Are you ready for the platform? Here is the honest question your organization needs to answer. Are you ready to build a platform? The answer isn't a simple yes or no. It is a score. It is a measure of whether you have the foundation in place to actually execute on what we have been discussing. Because you can have all the right ideas about orchestration and autonomous systems, but if your foundation isn't solid, the technology doesn't matter. Let me give you 10 questions. Answer them honestly. Do you have a clear picture of your critical automations? Not a guess or a rough sense, but do you actually know what they do, why they matter, and what breaks if they stop working? Do you have real monitoring on those critical automations? I'm not talking about someone checking logs once a week. I mean automated alerts that tell you immediately when something goes wrong. Do you have a reconciliation mechanism for the critical ones? You need a way to verify they are actually working instead of just assuming they are. Are your automations using managed identities instead of stored credentials? If you are still hard-coding connection strings or relying on service accounts that never change, that is a red flag. Do you have governance policies that actually constrain what automations can do? Or can anyone create an automation that touches anything? Is there a dedicated team that owns the automation platform itself? Or is automation just something IT handles when they have spare time? Do you have a governance committee that makes actual decisions about what is allowed? Or do individual teams build what they want and hope it works out? Do you have templates and shared components that make building new automations faster? Or does every automation start from zero? Is your operational model clear? When something breaks, do people know exactly who owns it? Is there an actual plan for how your platform evolves as technology changes? Or are you just trying to keep what you have running? Count how many of these you answered yes to. Honestly, if you have 7 or more, you have the foundation pieces to build a platform. The execution might be messy and there is probably work to do, but you have the structural thinking in place. If you have fewer than 7, you are not ready to focus on building new capabilities. You are in the foundation building phase. The platform can wait. What cannot wait is getting basic monitoring, managed identities, and governance policies in place, because that is your critical path right now. This isn't about shame. This is about clarity. Understanding where you actually are is the only way to plan where you need to go. The organizations that have built successful platforms aren't the ones with the fanciest technology. They didn't go after the newest tools or the most clever code. They are the ones that invested in foundational thinking first. They built monitoring because they needed to see what was happening. They implemented managed identities because credential management was a nightmare. And they established governance because chaos was expensive. Once the foundation was solid, everything else became possible. The organizations that failed tried to skip the foundation. They wanted to talk about platforms and agents and autonomous systems before they had basic monitoring in place. They wanted to build complex orchestration before they understood what their current automations actually did. And they tried to run before they could walk. Your diagnostic score tells you which camp you are in. If you are in the foundation building phase, that is not a failure. That is where most organizations are right now. The question is whether you are going to actually do the foundation work or whether you are going to keep pretending that patches and workarounds count as a strategy. The ones that do the foundation work end up in a completely different place by 2028. The ones that don't just end up managing more chaos. So where are you? Honestly, that score matters more than any technology choice you will make this year. The starting point. Where to begin? You have done the diagnostic. You know where you stand. Now the question shifts from what do we need to what do we do first. The biggest mistake organizations make right here is obvious in retrospect. They decide to build a platform and immediately open the IDE. They start writing code and designing logic apps, and then somewhere around week 3, they realize they don't actually have monitoring in place. They don't have a governance model or managed identities configured, and the infrastructure doesn't exist. The code they are building is sitting on top of sand, so they panic. They try to retrofit all of this. The project stretches from months into a year, and momentum dies. Stakeholders get impatient, and the project gets cancelled. And the old scripts just keep running. The organizations that actually succeed do something different. They accept that the starting point is unglamorous. They don't build a platform for 6 months. They build a foundation. And then, once that foundation is solid, the platform builds itself. If your diagnostic score was low, if you are missing more than 3 of those foundational pieces, your starting point is simple. It isn't complex. It is just methodical. Month 1 is pure assessment work. You are not touching code or designing architecture. You are inventorying what you have and documenting every automation that matters. You are understanding what each one does and identifying the ones that would break the business if they stopped working. You are measuring how often they currently fail and documenting their current failure modes. But you aren't fixing anything yet. You are just seeing clearly what is actually running. Month 2 is monitoring. You set up dashboards and create alerts. You instrument your critical automations so you can see when they are working and when they are not. You establish baselines for reliability and figure out what normal looks like so you can spot when things go wrong. This is not optional infrastructure. It is the thing that tells you whether your platform is actually better than what you had before. Month 3 is managed identities. You migrate your automations away from stored credentials and create system-assigned identities for each thing that runs. You assign those identities exactly the permissions they need and nothing more. This is the work that feels tedious in the moment, but it is also the work that prevents security incidents 18 months from now. Month 4 is governance. You establish the committee and define the initial policies. You document what automations are allowed to do and what they are not. You create the approval workflow that prevents someone from building an automation that shouldn't exist. This is the work that feels like bureaucracy, but it is actually the infrastructure that lets teams move fast without breaking things. Month 5 is templates. You take the patterns from your current automations and codify them. You create a starting point for the next automation that someone is going to build. It doesn't have to be perfect. It just has to save time. Month 6 is your first platform automation. Everything before this was preparation. Now you actually build something using the platform model. You use the monitoring you set up, you use the managed identities you configured, and you operate within the governance policies you defined. This is your proof of concept. And this is where you learn whether the foundation you built actually supports what you are trying to do. This timeline is not arbitrary. This sequence is not negotiable. If you try to skip to month 6 without doing months 1 through 5, you will fail. If you try to do the steps out of order, like building your first automation before governance exists, you will fail. The sequence matters because each step enables the next one. The organizations that get this right are the ones that accept this timeline. They are not looking for a shortcut or trying to compress 6 months into 8 weeks. They are doing the work in the right order and trusting that the foundation will support everything that comes after. The starting point is boring. It is not where the exciting part is, but it is where the real work lives and measuring success, what actually matters. The uncomfortable part about building a platform is that the metrics most organizations track are useless. They measure lines of code. The assumption is that more code means more work, which means more progress, except it doesn't. A platform with fewer, better organized functions that do more work is objectively superior to a platform with sprawling scripts that do less. They measure the number of automations. We have 50 automations now. We had 30 last year. That sounds like progress. But if you're building 50 fragile scripts instead of 5 reliable systems, you've just increased your operational burden. You didn't improve anything. They measure budget spent. How much did we invest in automation? $50,000. Great. Now what did we get for it? That's where most organizations go quiet. They spent the money, but they don't know if it actually mattered. None of these metrics tell you whether the platform is actually working. Here's what actually matters. The first one is time. How much manual work has actually gone away? Not theoretical time, real time. Before the platform, someone spent 10 hours a week on a process that's now automated, which adds up to 500 hours per year of freed up capacity. That person can now do work that's actually valuable instead of work a script could do, and because you can track this directly, it is not hard to measure. The second is reliability. Before you had a platform, automations were failing silently. Things broke and nobody noticed for days. Now when something breaks, you know about it in minutes. The failure might not be resolved immediately, but you know it happened. The mean time to detection dropped from days to minutes. Reliability became visible, which means you can actually improve it. The third is speed of response. When the business asks for a new automation, how long does it take to build it? Before the platform, you'd say 3 weeks. After 3 months of foundation building and 1 completed automation, you say 1 week. By month 12, you say 3 days. That speed difference is worth millions in competitive response time. And it's completely measurable. The fourth is confidence. This one's harder to quantify. But it's real. Before the platform, people don't trust automations. They double-check results. They run manual verification. They assume something's wrong until proven otherwise. After the platform, people trust that the system works because they know it's being monitored and reconciled daily, and that shift from doubt to trust changes how fast an organization can move. When users stop performing secondary verification on every output, the entire workflow accelerates. The last one is growth capacity. This is the one that really matters for long-term thinking. Before the platform, adding a new automation required the same effort as before. Every single one cost the same. You couldn't scale. After the platform, adding automation becomes trivial because you're no longer limited by the effort required to build each one, but only by how many problems you actually want to solve. That's the difference between a constraint on growth and unlimited scaling. Your measurement framework should be simple. How many hours per week of manual work are gone? Track it. How many automation failures are detected within 1 hour? Track it. How long does it take from "we need to automate this" to "it's running in production"? Track it. Are people trusting the automations? Survey your users. How many new automations are you able to build per month compared to 6 months ago? Track it. These are the metrics that matter. These are the metrics that tell you whether the platform is working. Most organizations won't track these. They'll keep measuring lines of code and automation count and budget spent. They'll feel good about their investment because they feel like they're doing something, but they won't actually know whether it's working. The organizations that win are ruthless about this. They define success up front. They measure it continuously. They stop doing things that don't move the needle. That clarity about what matters is the difference between a platform that's real and a platform that's theoretical. The obstacles. What actually stops organizations? Here's what actually prevents most organizations from building a platform. Nothing technical. The obstacles are purely organizational. They're about comfort. They're about inertia. They're about the gap between knowing something needs to change and actually being willing to do the work to change it. The first obstacle is status quo bias. Scripts exist. They work most of the time. They're messy. They're fragile. They'll break when the person who built them leaves. But they're here now. They're familiar. They have a rhythm. The operations team knows how to fix them when they break. And while there is an established process for this chaos, the reality is that people would rather live with known problems than adopt solutions with unpredictable risks. Asking an organization to move away from that familiar mess requires them to accept short-term friction for a long-term benefit they haven't seen yet. But here's the thing that usually shifts this. It's not the awareness that something's broken. It's the experience of total failure. When something goes catastrophically wrong, that's when organizations get serious about change. A critical automation fails and stays broken for days. Data is lost. A compliance deadline is missed. Before that moment, platforms are nice to have. After that moment, they're non-negotiable. The second obstacle is investment required. You're going to spend money, real money, $250,000 in year one. That's visible. The CFO sees that number and it's real. What the CFO doesn't see is the $500,000 you're already spending on operational overhead for broken automations. That money is invisible because it's spread across multiple budgets, lost in firefighting, and the cost of people working on problems that shouldn't even exist. Here's where this gets interesting. The organizations that move forward are the ones that accept the visible cost to eliminate the invisible one. The ones that don't are the ones that keep hoping someone will invent a free platform that magically solves everything without requiring investment or change. The third obstacle is the most serious. Organizational change is hard. You're asking the platform team to adopt new responsibilities. You're asking automation teams to work differently. You're asking the governance committee to exist. You're asking people to move slower to go faster. You're asking security to trust new processes. You're asking compliance to validate new models. All of that is friction. All of that generates resistance. When you propose this, you'll hear predictable objections. This adds bureaucracy. Teams need autonomy. The governance committee will slow us down. Why do we need all this structure? Each of these objections sounds reasonable. Each one contains a grain of truth, and each one is also wrong in the context of scale. You can run with autonomy when you have 50 scripts, but you simply cannot do it when you have 500. The governance committee feels like bureaucracy until you realize that without it, incompatible automations start getting built and they conflict in production. Structure feels slow until you realize that without it, moving fast means breaking things constantly. But the objections feel true in the moment, so people don't move. The organizations that move are the ones with leadership that says, this is the direction we're going. Not because it's comfortable, because it's necessary. They set the pace. They hold people accountable to it. They invest in training so teams understand why the new model works. They celebrate early wins so people see that the new way is actually better. Without that leadership, the obstacles win. The organization stays with scripts. They keep adding more. They keep hoping someone invents a magic solution that requires no change. And by 2028, when agents are mandatory infrastructure, they're still managing PowerShell. That's not because leadership is incompetent, it's because change is genuinely hard. But the organizations that accept that difficulty win. The ones that try to avoid it lose. The obstacle isn't the platform, it's the willingness to change. CI/CD for PowerShell, engineering standards. This is where the shift from scripts to platforms becomes real. Most organizations treat PowerShell scripts like documentation. You write them, they exist, they run. But nobody is policing the quality. Nobody is checking for standards, and nobody is verifying that a stranger could understand that code 6 months from now. This is where enterprises fail at scale. The moment you move from individual scripts to a platform, your code stops being a quick fix. It becomes enterprise infrastructure. That isn't a metaphor, it's a requirement. In a real platform, every script repository is version controlled, every change is tracked, every version is retrievable. When a script breaks something in production, you have a history. You can see who changed it, when they did it, and why they thought it was a good idea. For anything touching production, this is non-negotiable. Version control means you're using Git. You're likely on GitHub. You're creating branches for changes and using pull requests instead of committing directly to the main code. A pull request means a second pair of eyes reviews the code before it ever runs. They check for mistakes. They verify standards. They catch the small things the original author missed because they were too close to the problem. If you've never worked this way, it feels like bureaucracy. It feels like friction. But the first time someone makes a breaking change and you revert it in 30 seconds because you have a history, you finally understand why it matters. Enterprise infrastructure also gets tested. Not, I ran it once on my machine testing. Actual test cases. You need unit tests to verify individual functions and integration tests to ensure the script actually talks to the right systems. You have to test against failure. What happens when the database is down, the network times out, or the input data is complete garbage? In the PowerShell world, this means Pester. Pester is the framework that verifies your functions work exactly how they're supposed to. You run these tests automatically every time someone commits code. If the tests fail, the code doesn't merge. This is where real quality control happens. It's not about testing by hand. It's about automated rigor that runs the same way every single time. Finally, enterprise infrastructure gets released through pipelines. You don't copy files to servers. A deployment pipeline means you aren't logging into a box to run a script. You're triggering an automated process. The pipeline pulls the code, runs the tests, and if everything passes, it deploys to staging. Once you verify it there, it moves to production. Every step is logged. Every deployment is auditable. This requires GitHub Actions or Azure DevOps to define your deployment as code. The process becomes repeatable and consistent. It no longer depends on a specific person remembering the right way to do it. For critical automation, this isn't a luxury. It's the infrastructure that lets your team move fast without breaking the world. The shift from scripts to platforms is a shift in mindset. You aren't just writing code anymore. You're contributing to infrastructure. It means code reviews. It means automated testing. It means accountability. It's uncomfortable at first, but once you've built a platform this way, you can't imagine going back to the old model. Organizations with real platforms have professional engineering practices. Organizations that are just managing scripts don't. That's the difference. Transition. Professional engineering requires the right tools, but it also requires one more thing: understanding how your code actually fails when it's running at scale. Secrets management and key vault integration, managed identities solve a huge problem. Your functions and logic apps don't need to store credentials anymore, but the moment your code runs outside Azure, things break. Maybe it's an on-premises server, maybe it's a third-party tool or a GitHub action. Suddenly you're back to managing secrets, and that's where most platforms collapse. Here is what happens in reality. A developer needs an API key for an external service. They put it in a config file. They check that file into Git. 6 months later, someone finds that key in the history and uses it to compromise the service. Or worse, they find it after the damage is already done. This happens because people treat secrets like configuration. They aren't the same. Configuration changes, but secrets rot. The longer a secret exists, the more vulnerable it becomes to being leaked, sold, or accidentally exposed. The platform approach treats secrets as managed infrastructure. You never store them in code. You never check them into Git. You store them in Azure Key Vault. Your applications fetch them only when they need them. Key Vault handles the security. You handle the policy. This requires a pattern most developers aren't used to. When your code starts, it doesn't read a local file. It authenticates to Key Vault using a managed identity. It fetches the secret, it uses it, and it never keeps that secret in memory longer than it has to. In a logic app, this is easy. You use the Key Vault action and reference the secret by name. In a function, you use the Azure Identity and Key Vault packages to create a client and pull the value. It's a standard repeatable code pattern. But the operational side is where this gets interesting. Someone has to manage the lifecycle. Secrets expire, they rotate. Occasionally they get compromised. Here is the model that actually works. When you create a secret in Key Vault, you set an expiration date. 90 days is standard for critical keys. 30 days if you're touching regulated data. Key Vault sends a notification when that secret is about to die. Your team can rotate it manually, or better yet, automate it. You can use a function to update the secret in the external system and then update Key Vault. It sounds manual at first, but once the pattern exists, it's fully automatable. A function can call an API to generate a new credential, update the vault, and test the new key before it ever kills the old one. Organizations with real platforms automate this. The ones managing secrets manually spend hours every quarter rotating keys. The ones with automation spend nothing. Then there's access control. Not everyone on the team should see production secrets. Key Vault has fine-grained control built in. You can allow a managed identity to read secrets while allowing a user to rotate them without ever seeing the value. You can audit every single access. You can revoke access the second someone leaves the company. Without this, secrets are a governance nightmare. When someone leaves, you don't know what they copied. You have to rotate everything just to be safe. Without Key Vault, you're doing that manually for dozens of systems. With Key Vault, you manage it through one interface. The shift from storing credentials and files to managing them in Key Vault is the shift from operational risk to operational control, event-driven architectures and graph subscriptions, everything we've built so far. The managed identities, the governance, the reconciliation layers, and that's just the foundation. But what actually uses that foundation? In 2026, the answer is event-driven architecture. Moving from scripts to platforms is really a shift in how you think about time. In the old model, you think in batches. You do work on a schedule. Run the sync every hour, process the queue every night, reconcile the state every week. But this creates a gap. A customer places an order at 2:47 p.m. Your system doesn't even see it until the 3 p.m. batch run. The delay is built into the design. In the event-driven model, you respond the moment it happens. The customer orders at 2:47 p.m. Your system knows about it 3 seconds later. This matters more than it sounds. A 30-minute delay seems small on its own. But when you multiply that across thousands of processes, things start to break. Data gets out of sync. Assumptions fail. Work just sits there waiting for a batch that hasn't started yet. This is where graph subscriptions become critical. A subscription means that when something changes in Microsoft 365, your system hears about it immediately. A new email arrives, a file gets updated, a user is created in Entra. The subscription fires and your system responds in seconds instead of waiting for a clock to hit the hour. But immediate response creates a new problem. What happens when 1,000 events arrive at once and your system isn't ready? The answer is a queue. Events hit your subscription endpoint, but your logic app doesn't process them yet. It drops them into a service bus queue. Then a separate system drains that queue at whatever pace it can actually handle. Spikes in activity don't crash your system because the queue absorbs the shock. Your system just keeps processing steadily, no matter how many events are piling up. This is where platform thinking gets interesting. You aren't processing things one-to-one anymore. You're moving to an asynchronous model where the queue provides the resilience. If your processing system goes down, the queue stays up. When the system comes back online, it just picks up where it left off and clears the backlog. The Delta query we talked about earlier fits right into this. It isn't just for reconciliation. It's the safety net for when a subscription misses an event. The subscription handles the real-time flow. The Delta query runs once a day to catch the gaps. Your processing system doesn't care where the data came from. It just sees work in the queue and does it. Real enterprise work is messy. An order arrives. You have to read it, check inventory, call a fulfillment system, update a database, and send a confirmation. If the fulfillment system is down, does the whole thing stop? Does it just fail? The platform pattern breaks this into steps. The subscription triggers and queues the order for validation. A function validates it and either moves it to the next queue or sends it to an error log. The fulfillment function then picks it up and updates the database. At every step, the failure is isolated. A problem with fulfillment doesn't stop the validation step. A system being down doesn't break the entire pipeline. We call this event choreography. Systems don't just follow a list of instructions, they react to each other. It works like a conversation instead of a rigid procedure. The organizations building real platforms have made this mental shift. They don't ask, how do I call this system? They ask, how does this system emit events that others can react to? It's a different way of working, but once you have it, scaling becomes manageable. You aren't building brittle connected pipes. You're building a fabric where systems talk through events. AI-enhanced workflows and the 2026 landscape, the infrastructure we've been talking about, the subscriptions, the queues, the governance, these aren't just nice-to-haves. They are the only reason AI works at scale. Most companies are treating AI the same way they treated automation back in 2020. They see a new tool, they want the results, so they build something fast, and then the problems start. Data governance breaks because the AI is touching systems with no permission models. Security is at risk because there are no audit trails. Costs explode because nobody realized what happens when you run a million operations. The platform approach stops this before it starts. Look at a real scenario. You want to use generative AI to help your support team. The plan is to feed customer data to an LLM, get a suggested response, and let the agent send it. The benefit is clear. Your team handles twice the tickets. In an unmanaged model, you just connect the API and go. You pass the data, you get the answer, you're done. But the problems show up later. You realize sensitive data is leaving your network and going to an external model. That's a compliance failure. The model hallucinates and gives a customer bad advice. That's a brand failure. Then you see the bill is $50,000 a month. That's a budget failure. The platform approach is different. The AI isn't connected directly to the support tool. It's connected through your orchestration layer. Only safe, classified data ever reaches the model. Every response is logged. Every cent is monitored. If the cost hits a limit, the system automatically scales back the feature. This requires real infrastructure. You need a governance layer to decide what data can leave. You need a monitoring layer to track what the AI is actually doing. You need a reconciliation loop to catch the hallucinations. It's more complex than just plugging in an API. But it's the difference between a system you can trust and a security incident waiting to happen. By 2026, the companies winning with AI are the ones who built this foundation first. The ones moving fast are the ones who will have to rebuild everything later at a much higher cost. Or worse, they'll have an incident that forces them to shut the whole thing down. The agents we discussed earlier aren't a separate thing, they are an extension of the same pattern. When an agent creates a record or updates a system, it flows through the same orchestration layer. The same governance applies, the same audit trail records the action. This is why platforms matter. It's not about being elegant, it's about being operationally survivable. You can use the most advanced tools in the world without creating a risk your company can't handle. The real value isn't the AI itself, it's the infrastructure that makes the AI safe to use. Stop thinking about the next script. Stop thinking about the next automation. Start thinking about the infrastructure beneath it. Because by 2028, the winners won't be the ones with the most tools. They'll be the ones with the strongest platforms. Your mandate is clear. Build that foundation now, before it becomes a crisis.